Alright, so we're going to look at this example here. We're asked to find V out here, and we're given Vg is 75 cosine of 5000 t, and then of course we've got a 4 microfarad capacitor, 110 millihenry inductor, and another 4 millihenry inductor, and then a dependent power supply. Now this is just a word of caution to all of you when you're working on these problems in your homework. Be sure to take your time and don't rush through the problems. I've been trying to rush through to make this video, and now this is my third attempt on the video because I've made errors, significant ones that were just like, I don't want to have to go back and try and correct it in the video. So let us get through here, and maybe third time is a charm here on this. So how do we tackle this? Well, of course we know we need to put everything into phasor notation. So, whoops, I don't know what happened there. Come on, screen, there you go. So we know that omega is just 5,000 radians per second. And then if we want to convert Vg to a phasor, we know this is just 75 at an angle of 0 degrees, which is the same thing as just 75 volts, which is convenient. Then we have to, of course, compute the impedances of my components. So the capacitor is minus j over omega c, minus j over 5,000 times 4 microfarads, which is negative j 50 ohms. And then we have two inductors. So this will be the 110 millihenry inductor. So this, of course, is just j omega L, which is j 5,000 times 110 millihenries, which gets me j 550 ohm. And then we have the impedance of the 4 millihenry inductor, which of course is still just j omega L, which is j 5,000 times 4 millihenries, which gets me j 20 ohms. Alright, so now that I have that, I'm going to actually redraw my circuit here. So I'm going to redraw it with my 75 volt voltage source. My capacitor is minus j 50. And then I have I delta still going through there. And then I have my j 550 ohm. Then I have my dependent power supply. And this is 100 I delta. Then I have another inductor and my 10 ohm resistor. And this is a J20 ohm inductor. Alright, now technically you can use any method we want to, but if you look at how many nodes there are in this problem, we've got 1, 2, 3, 4, 5. Now we do know some of these, like this would be ground and that would be 0 volts. That makes this 75 volts, but I still have 3 unknown voltages, which means I'm going to have 3 equations. So let's see maybe if there's another way to do this. Well, if I look at loops, for instance, and I say I have a loop here, I1, and then I have another loop, I2, you know, that gets me I1 and I2, and we can clearly see that V out is just simply 10 times I2. I mean, that's just Ohm's law. So let's go ahead and do loop here. Now before we write down some of these equations, let me slide this up, we should probably make note here that we should also see that I1 is equal to I delta. So that means that this dependent power supply is really just 100 I1. Alright, so let's write my equation for loop 1. So I start with the voltage source. I have negative 75, and then minus J50, excuse me, times I1 plus J550, I1 minus I2, and then we're coming into the negative side, so that'd be minus 100 I1 equals 0. Now if we're careful rearranging terms, I'd get negative 100 minus J 500 I2. So let's just double check that since I've messed this up so many times. Negative 100 I1 minus 50 I1 plus 550 I1. Okay, so that's correct. And then I would have minus J 550 I2. So that gets rid of that one. And then that's equal to 75. Okay, so we're good. So that's my first equation here. Now we'll go ahead and do loop 2. Loop 2. And I'm just going to start at the J20 inductor. So I have J20 I2 plus 10 I2. Now I'm going into the positive side, so that would be plus 100 I1 plus J550 I2 minus I1 is equal to 0. Alright, and then what I see here, well, let's combine like terms again and see what we get. So I'd have 100 minus J550 I1, and then again being careful that takes care of this one and takes care of that. And then I had have plus 10 plus J570 I2 equals 0, because that takes care of 10, 550 plus 20 is 570. Alright, so then this is my second equation. Now remember, if you have a calculator that cannot do complex numbers and matrices, the way you would set this up is you would set this up as negative 100, negative 500, and then you'd put 500 here, negative 100. Now this is 0. This would be negative 550, 75, 0. So it'd be negative, I'm sorry, we'll do the conjugate there, so this would be 550. And this would be 0, 0, 75. Alright, then let's do the second equation. So we have 100 minus 550, 550, 100, 10, 570, minus 570, 10, and then a bunch of zeros. So I'm going to go ahead and solve this on my calculator here. I'm going to pause the recording of the video. Well, and you've seen the screen jump because I did it again. I wasn't careful, and I have an error in my equations here. So first off, this should be plus J500, and this should be I1. But those are relatively small, so let's go ahead and just fix it. What that means is this is going to be, that's the only change that we have. So I have positive 500 and then negative 500. Alright, so now I am going to solve this here. Okay, so my calculator gave me that I1 is equal to 0.5 plus J2.5 amps. Now my calculator, and this is why sometimes you have to do something that makes sense, gave me that I2 was negative 83.3 repeating times 10 to the negative 15th plus J2.5. But this is essentially 0 when compared to the imaginary part, which is 2.5. So, and actually the actual answer is 0 plus J 2.5 amps. Alright, so if that's the case, we can get our equation for V out. So V out is simply 10 ohms times J 2.5 amps, which is 25 volts, which is equal to 25 at an angle of 90 degrees. And so then we would get that V out is equal to 25 cosine of 5000 T plus 90 degrees. Alright, so we got through that problem finally. Whew.